The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong. I'm here with Mr. Dane DuPont on behalf of Hawaii Tracker, hawaiitracker.com, bringing you guys another Hawaii volcano update. Today we'll start with Kīlauea. We'll touch briefly on Maunaloa, but there's not a whole lot of change there to kind of just give that one away. But here we are on Friday, February the 12th, a couple days away from Valentine's Day. And so I started off showing you guys this image released by the USGS today of where the lava is leaving the west vent up here and flowing around this island, which has now become a heart-shaped kind of thing. So I can draw it out a little better for you guys right over here. Pardon my horrible, horrible drawing there. There you go, something like that. So yeah, it's the 54th day of the eruption so far. We're almost at this two-month mark here. And we're starting off just showing you guys some of these images released by the USGS. There's not a whole lot of major change. The volcano is re-inflating, repressurizing a little bit. And it seems like, if you look at this photograph at least, this whole island is mostly underneath the lava surface now. Whereas before it was sticking above quite a bit. So it seems like the lava might be a little bit more gassy as well. More frothy, so to speak. So it kind of is foaming higher and reaching that higher level. And correspondingly, this little ledge here at the back is also dropping. So this is the west vent on Kīlauea volcano, filling in this pit crater of Halemaʻumaʻu. And this photograph here from a couple of days ago, I believe. Let's show you guys this one from yesterday. In a wide angle view, you can kind of see that because we had a reduced, presumably pressure from the reduced tilt on the volcano, the lava was only covering this smaller part of this western vent that's kind of bean-shaped around this big rafting island. And I can maybe zoom in on that a little bit more. And so we can kind of see there that there's still a little bit of a ledge, but not nearly as much as before, and the lava is coming right up to it, obviously. Over here, it's not quite as clear. It seems like there's, if we pan over, there's lava making it all the way almost to the bend of this island, but maybe not visibly quite that way. So it may be that you have a thicker crust forming back here. In that case, the lava is having to push its way up and over on here, rather than just having to flow and being able to overturn its crust and replace it. So now it's maybe hardened long enough that you can't just do that as easily. So that's part of this whole eastern lid that seems to all be lifting as one. And so we'll show you guys the thermal video later, and you can kind of see how when the volcano has been repressurizing, this lid has been rising very slightly as well, kind of leaking out of the edges, which you don't quite see in this photograph. Still beautiful, beautiful, beautiful view. You see the fumes, a lot of steam, some sulfur. It's kind of hard to tell which is which sometimes from these photographs, but when you see the color of the wall a little bit yellowish, you know, good indication that's sulfur coming out of there. So some mix of both of those, and the water can come out both of the magma and be entrained by the groundwater that's trying to come near it. Both of those, in both of those ways can you get water, but even without groundwater, you'd still have water coming out of the magma. All right, so a few more images here. This is the west vent. Here's our heart-shaped island right here in the front. And you can see the lava is coming around it. There's a bit of an overflow over here on the back. You can see a little bit of the lava glow kind of crusted over, not really flowing that much, but you can see there's some flow going this direction. And if we can pan over a little bit more this way, maybe you can see the margin of it. So this was an overflow that came over the edge of this levee, which is right here. You kind of see the breach happening right there still. Coming out of that west vent right in here, there's like a levee right in here, and then right next to it, it's looping right around and was briefly pouring right out of the lava lake through this little breach. It's about that wide right in there. And so that's kind of stopped. So that's kind of we'll see what that looks like on a thermal webcam a little bit later. Just going to back that up, and still quite a lot of gas coming out the top of this west vent. And the emissions are down according to USGS. They're we'll see that here shortly as well. But lava has not stopped coming out yet. It continued despite all the changes in signals. Less gas and more tilt, kind of contradictory things. So here's our tilt signal in the last 2 days. You can kind of see it's a pretty much up from kind of like that, and then maybe here at the end, maybe it's flattening out a little bit. So much more linear, a lot less curve to this on the back end of this tilt. It's interesting how that's come up. Looking at here this past week version of the plot, and this being the back end of our last deflation-inflation event, where the tilt went all the way down and came back up at a much steeper with that kind of curvature that we're used to seeing. So just little minor differences. It's hard to say that it means anything, but when you look at these things this often, then you see all those little changes, whether they're meaningful or not. Well, here's the last month. You can kind of see here's our double large deflation-inflation, and kind of a small one kind of seem to pick up. And so we're actually at a level higher before than we came up, that we left from before, and it's kind of a higher level than we've been for a while, right? Even though it has not that much, or still within 5 microradians or so. You can kind of see here's our earlier doublet, deflation-inflation, deflation-inflation, and then the back end of this one was also kind of a long, gradual rise as well. So that's all we can kind of say. We can see that the GPS distance across the caldera, zooming as far as I can here, has been mirroring the tilt, so kind of getting farther apart, closer together during the deflations, farther apart, and it seems like it's kind of doing that. But the general trend still being an upward one, right? So still spreading apart on net across all those small changes of deflation-inflation. Right, there's not quite as much to see on Kīlauea today. It's kind of been business as usual. Here's the USGS webcam for the past 24 hours. And you can kind of see we're looking from the west, so north is that way. The remains of the north vent are kind of embedded in this solid crust now. And here's our big island with this little cape. It's probably pretty big in real life. It looks like a little knob right in here, but we're forming a little bay and a little cape, right? So maybe this is some sign of this getting weathered. We'll have to go back and look at the time lapses and see if you can see any of that happening in the future. But otherwise, you don't see any action behind this big island here, despite the fact that for the last 24 hours have been 48 hours even inflating. So the lava is lapping up onto these edges, but not really going up onto here as much. It seems to be going underneath the crust to the edges where we see still these squeeze ups on the side there, and possibly a big one down here just south of the west vent. It seems to come not over top of the rim, but actually pop up from below. Hard to tell when it's only every hour you get an image, but I don't see any hot heat trails anywhere, and it's a gap in between. So I'm going to kind of see a little bit more up here. So the whole thing is rising. We'll look at thermal in more detail here in a second, but if we look at the USGS plot, it is still showing an increase. We have a couple dips corresponding to that deflation-inflation, but we're now at our all-time high. We look at the USGS update, and we'll kind of look here. All-time high being measured right over here, right below the west vent. So that level is rising, and then everything else seems to be rising as well. So there's some variation of the lava going up and down on the actual ledge. See if I can zoom in on that a little bit. It's the last 24 hours. You can see a little bit of change of the lava going up and down the ledge. That's more a change of how frothy and how gassy it is. It can be frothier, and then the whole thing is less dense. It'll sit higher. And so the island might appear to sink, but actually the lava has risen relative because it's bubblier. And if it's less bubbly, it'll kind of recede down as well, and the island might appear to rise or float.
Hey Phil, we have a $5 super chat from Backyard Gaming who asks, can you get a view of the lava lake from any lookout point yet?
Not yet. There have been reports and people trying to catch bits of spatter, and I haven't been convinced of anything. But maybe there are some glowing little bits. We know that glass is flying out of there, but no really good view yet. The glow has been incredible. We'll show you guys some of our viewer and submitter contributors to Hawaii Tracker photographs later on. You guys can kind of see some of the views that are to be had. So mahalo for that.
Yeah, thank you for your support on that super chat.
So yeah, so a couple effects here. It's going to be hard to tell, like looking forward, right? Whether this attachment of this thinner crust does anything to stop this much larger island from any kind of rising and falling. So presumably, as the lava volume is rising in total, kind of density independent, then the island would rise as well. And then on top of that, you have these smaller changes, right? You can maybe even see it. It's hard to tell if the camera is rocking here. I try to look at this front view rock, and I see it is moving a little bit too. So it could be the wind, or imagine that as the lava is filling in here, we're showing the GPS moving apart. All that ground is where this camera is sitting. So the camera could also be wiggling just from the ground itself it's on, being wiggling as far as, and also the wind, and then also whatever other adjustments to the ground are happening around there. People walking around or what have you. Sometimes that happens by accident. So, but yeah, the double effect there. The island may be rising up. It almost looks like it does, but that might just be the effect of this little knob right in here. Let me go back to this thermal here for the last 24 hours. I'm just going to point out here that we are also having overflows over here on this north side. There's one caught right in there, another one caught right in there, another one caught right in there, right? So sometimes it does appear, if you're looking from this west angle, kind of vertically down at the bottom of this pit, there's actually a glowing hole right here in the foreground, and right behind that's where that flow is going below it, much below it, further down. It's kind of hard to tell what's going on in the details right there. See if I can get it to zoom in at all. It's going to see a little better. There's actually some hills right here in the front, and then lava flow going behind it. But it might appear like lava might be coming out. From there, it is actually not. It's flowing from doing that U-turn right over there out of the vent we described earlier. Okay, so let me switch now and kind of go to the little bit longer time lapse. This is just the last 10 days or so. So you can kind of see when the lava levels were a little bit higher and we're still going around the backside of the island, and you still had some crustal overturning, although you can kind of see now as the lava pressure goes down, it recedes. Now we're back with these little bays right in here. And that's what, even though we've now come all the way back up to this corner over here, we haven't quite come as far. You can see the activity picks up. These little islands here in the foreground by the vent are disappearing, reappearing. You can kind of see the wake on that one. That's that backside of the heart. Yeah, and then overflows, squeeze ups. There's that bigger overflow back over here. All right, so what I'll do is I'm gonna just do a whole rocking back in 10 days, all the way forward. So you can clearly see the lava levels go down and up. And the island is not convincing that it really moves at all in there. If it does, it's very, very minimal. At least so far, based on these views. Maybe bobbing a little bit. Could be a few meters here, a few meters there, and that's as fast as the lava lake is rising. So it seems like the actual how much lava was receding is much greater than how fast the lava is rising. So hard to see that change on the island right in there. We'll see if it stays stable and what we can see in the future here. But that's where one thing we're keeping an eye on is how it rises in different ways right in there. All right, let's move on from the thermal time lapse here. And no, let's not do that one yet. Let's this was our S1 cam. We're looking from the south. And our most recent figure from the USGS as far as the depth of the lava filling below the west vent, 216 meters, 708 feet deep. So it's actually resumed filling, refilled what it lost during a deflation, and then it's now at an all-time high underneath that west vent. And the most recent measurements in SO2, February 11th at 1,200 tons per day. That's lower than anything in pre-2018 lava lake, right? So that's lower than that lava lake era. Still trending downwards. And if we look at the graph, that data point is way down here next to the zero. A little bit hard to tell. And this bottom line is minus 10,000, 0, 10,000. So 1,000 is right there, 1% of that way up on that plot. So a little bit lower, the lowest measurement we've seen so far. It's kind of touching the line here at the bottom. And some other ones were close, 2,000 range. But this is the lowest one been reported to my memory so far. And of course, there is some VOG still. Here's a VOG forecast from the VOG mapping project. Winds blowing northeast, southwest, and most effect in South Hawaii, and of course, wrapping around to the Kona coast as well. All right, we'll be taking your questions here at the end of our whole volcano update, both volcanoes. So pass them along to Dan. He's collecting all the questions. We'll get to those here shortly. But moving on from the gas, I want to kind of just turn to show you guys just one more thing that was released. This is a video, aerial footage released today of 3 days ago. This is a aerial view looking into the pit of Halemaʻumaʻu. So have it very slightly sped up here. You can kind of see there's a west vent. There's the island again, or the raised edge of the pond. It's kind of right in there. Going all the way around to here, you can kind of see. On this side, a little bit less clear, but all the way into there. And coming out of the west vent, down there, quite a lot of gas. You can see a little bit of this old road. Look closely, it'll kind of come on screen over here. And this upper block that's down dropped. You can kind of see this lower horseshoe-shaped block that's over here in the west, above the west vent. And this road coming into focus again. Draw its trace, it's like right like that. Watch it come around. That's just one view, not a whole lot of change. Looking at it kind of every few days at a new kind of aerial view. So as a treat today, I wanted to kind of a bonus put together a little short compilation here of aerial views since eruption began. So this here is December 21st. And you can see that was the very beginning. The north vent was active. Still, the west vent started off stronger, but then weakened until the north vent drowned. The west vent becomes more active. There's our road in the foreground once again. Kind of thing. The eastern edge was active. It's starting to freeze right around this time, mid-January, early January. By February, it's all solid, and here's our latest frame in that sequence. I'll go through it one more time. And December 21st, December 22nd, 26th. See how much deeper it looked on those first few days. It's really striking after staring at it so long recently with its current, much deeper depth. January 12th, this is already a month ago. So from a month ago, not looking too different. Everything in the east here is frozen in place. The island is kind of frozen in place. Maybe it's rising and falling, but it doesn't seem to be doing any kind of shimmy back and forth that we can tell in any direction. So it's at least just up and down, whatever it's doing. And kind of retreating, lava retreating further and further closer to this west vent over here. That's been the pattern of the whole last month or so. All right, so we'll turn to look at earthquakes. And as far as earthquakes, nothing in the last hour here, but you can kind of see the oranges, a few on Maunaloa Summit. That one is at 2.4 at above sea level, so shallow, 2.4, 2.1, 2.0. A little bit bigger, but still there's 3 above 1.6 in that range. It's not a whole lot. A lot more still in this deep Pahala feeder zone that is not really meaningful to us on a surface, apart from knowing that there's still magma coming in and this volcano is not dying off anytime soon. None of these are, apparently. A couple adjustment ones on Kīlauea Summit here. That is a 1.9 and a 2.1 and 1 on a south flank over here. But very, very low activity overall, as has been common since eruption began. We're seeing big clouds that look like this on a whole summit and upper east rift and upper southwest rift region before the eruption began. So it's really, really quiet. Not a whole lot of pressure on the flanks, it seems like, over there. It's really this upper caldera distance that's the most extension happening right in here. All right, that's what that line of Kīlauea Summit is actually showing us. So even if it's this whole south flank moving and magma filling just the space because it can, it's still a net filling of magma and spreading apart over the two sides of the caldera. All right, so as you can see, Mauna Loa, zoom in a little bit more. It's kind of typical summit region and upper southwest rift, and kind of one little zone to the northwest over here. So typical areas, nothing surprising there. And look at the map for Mauna Loa here for the last month. This is showing all the little ones as well. There's a summit caldera, upper southwest rift, northwest cloud section, and we'll look at the counts here. And for the past month, we're looking at earthquakes per day. The top of the graph, so it's 25 earthquakes a day. So we've been around 20 earthquakes a day, a little bit above, maybe 15 last week.
Before you go into full-on Mauna Loa, we do have a super chat from Backyard Gaming, $5. If the chamber is refilling, is that an indication that eruption will continue for a while?
That is the biggest clue that it would be doing that. And of course, that's arguing against the gas values. The gas values might be the ones telling us maybe the magma is not getting out, or what's getting out is not as gassy, and that would kind of indicate that whatever pathway it has, that it would end sooner than later. So those two signals are kind of at odds, and that's kind of a curious thing to wait and see. Yeah. We don't have a whole lot of Mauna Loa today. It's just a couple quick things here. Just earthquake counts are normal, same places as usual. GPS is doing the same as usual, and that's basically it. Nothing on a tilt. We're still spreading like we were last week, but nothing that's abnormal beyond background levels at this point for Mauna Loa. So business as usual over there. That'll deserve our attention at some point in the future, but not anytime real soon, apparently, from what we see this week. So we'll do some viewer photographs here, and then we'll turn to the questions here shortly. And we'll start off with Michelle Weisman. I'm sorry, I'm butchering your name. Madame Pele last night view over here from Kīlauea summit. Nice stars in the background, glow in the clouds. Our second feature, Mr. Harry Durgan, frequent contributor to Hawaii Tracker. Lava Noir, Kilauea Crater, Kanakakoi Overlook. This is the edge of the overlook right in here, and photographer, people looking at the lava glow. February 7th. Next, February 11th, Stephen Davies, perhaps. I'm sorry, I'm terrible with remembering the pronunciation of names, but very beautiful photograph comes in here. You can see a nice exposure on the stars in the background and nice lava glow, a little more artistic there. Cody Yamaguchi, another frequent contributor. Here he is, Pele's early morning dance with Mahina. Blessed to witness creation at its finest. Mahina, the moon. So back over here, the clouds. All right, that's Cody. One more to finish off, and it's Mr. Harry Durgan once again. February 10th, Kilauea Overlook. Let's see some living shrubbery, native vegetation here, and looks like what remains of a tree over there in the background. We can see the nice down-drop block over here on the left. And the inner pit with all the glow. So nice view there from somewhere around Kīlauea Overlook. All right, and so I want to mention this week once again that we are brought to you guys by Kaleos. Kaleos innovated Hawaiian-inspired local cuisine. Really appreciate the support. They're open for dine-in and takeout every day. Reservations, or call in and check out their website for more information. Then you want to add something about Kaleos and
Right, it's just a really nice spot for either local cuisine or visitors. I frequent there weekly. It's really a good environment. They take proper precautions, outdoor dining as well for those that like COVID safe dining. They have that pickup, no delivery, but they have all the other options right there. Right in Pahoa, good. One of the things that really sets it apart is it actually has parking. And a lot of places you're struggling to find parking. Kaleos has it. Kaleos has great food and great environment. So yeah, check them out. They have their menu online and all of that available for you. And we're going to get into the question and answers here in a second. We have some good ones today, Phil, and some where you were struggling with pronunciation. I'm going to really be struggling.
Yeah, that's what we got. So mahalo Kaleos.
Yep.
And yeah, we'll turn to questions now, and we'll see where that takes us, and we'll go from there.
All right. So first one is the one I'm just going to try and get out of the way right now. Tanya asks, how does black runny lava of Old Doña Lingai compared to Hawaii lava?
Oh, so something that my memory is a little fuzzy on, right? But that's a very special kind of lava at Old Doña Lingai, right? I'm sure that some of our viewers I know have actually been there and done a lot of work on that volcano. But it's something where there's more carbonate right in the lava. And so it's got a lower melting temperature, and so it makes it runnier, and so it actually glows a different color. It flows similar, but because it's a little lower temperature, it's not quite exactly the same thing. So that's as far as I'll go because my memory is hazy on it. But that's the basics of it. I can maybe give a better answer if I can refresh it. I don't want to hang myself on a string out here without really recalling that.
All right, we'll come back to Kīlauea then.
Take off my Kīlauea blinders once in a while, but not very often.
Big Ron asks, does the increase in tilt mean that there is more material getting pressurized beneath the caldera?
It could mean that. It could be a reflection of that long-term supply rate. We've seen the tilt since really 2000 2004 time kind of went up in a pulse and then kind of took a second pulse to come, really since that second pulse in 2010 maybe or so. It's been steady, right? Through the 2018 eruption, that's what essentially led to it. It's refilling the same rate, then yeah, that could be, even if this particular eruption closes off for whatever reason, let's say that this particular pathway of magma is getting clogged because the magma is getting too gooey and too degassed, something like that, it would seem that you'd have another eruption not that long later, because you have building pressure going on too. No matter of when and how it cracks out and all of that's the less certain thing. No one knows, of course. But that would be on the table for sure.
All right, so let's keep it on the tilt. Matt Hakur asks, the tilt in the GPS is going up, but the gas is very low. It looks like a new vent might open up maybe next to the western vent, or the existing west vent might get more active again. What are your thoughts?
Yeah, that's essentially another way to say what I kind of just finished saying for the last answer. Yeah, I would agree. It seems like
exactly.
It could open up another vent, but it could be that if there's, maybe the volcano can spread and build for a long time without actually cracking. We saw that before the eruption. So if this vent actually clogs up, it could take weeks to months for it to reprime, possibly, even if it's spreading that entire time and every day we're thinking, oh, maybe today will be the day, maybe today will be the day. It can do that for a long time, and there's really no way to tell, right? So I would agree, yes, but I wouldn't bet on a time frame being super short necessarily. How I would answer that.
All right, so we have a question here from Dave on Facebook. At this pace, how long till lava fills and overflows the caldera?
Oh, I think it's going to be a while still, right? I think it's if we say the whole caldera, then it's a matter of years, no matter which way you slice it. If you're looking at that innermost crater, maybe a few more months if it can keep up a rate, right? But kind of the decreasing gas, normally the gas is correlated with the amount of lava coming out. So if gas levels are that far down, we know lava is still coming out, but maybe if it's less gassy or there's less of it, it's kind of hard to tell how that balances out. But in any case, that's the real mystery, is that 1,200 tons per day is a really low number for this volcano during an eruption.
Right. And then the caldera itself is just humongous, and then to get out of that is going to take a long, long time. Even if the eruption rate kicks up and really starts going, it's just there's a ton of space there.
Yeah, kind of really flares a whole bunch the higher you fill it.
Right, and it isn't like if it was going to try and completely escape the caldera, one of the first places it would try and go would be into Kīlauea Iki.
No, it probably flows out to south before it does that.
Oh, south before it gets there.
Yeah, south into the Kauai Desert. I mean, but that's assuming like it's overflowing from that same point in the bottom, and as we know, you could have an eruption every year that lasts a couple months and comes out of a different crack. And there's been eruptions on Byron's ledge that separates Kīlauea Iki and the main caldera. So if it erupts on top of there, then lava could certainly go in Kīlauea Iki again.
Right. All right. So Alex asks on YouTube, he had a question about relevant forces in lava fluid dynamics. It seems like there is a lot of different things, like convection currents and the weight of lava. Are there other forces at play?
Yeah, there's a lot, obviously, right? The way that I kind of try to simplify it, because that's kind of what I try to do for everyone, is simplify things, and maybe I'm cutting a couple round corners and smoothing them off a little bit and making a few simplifications. But I think of it as essentially two things. One being the viscosity of the lava, right? And that's kind of a complex factor. Viscosity being like how easily does it actually flow. So that could involve the chemistry, the crystallinity, the temperature, the gas content, that kind of thing, right? That property on it. And the second one is the stress field. And so these are both complex variables. The stress field being the 3D forces acting on that whatever parcel of lava from all different directions. So you always have gravity, for example, and then you might have slope. So you might have some, inclined force, and it's the combination of all those things, right? The actual gas throwing it out of the vent and kind of all those things mixed together, right? So, but essentially, that's what gives you that whole range of textures, as I think of them, of cooled lava from pahoehoe to to whether they're Pele's tears or Pele's hairs, and chemically there's a lot of small variations, but they're really all the same thing, right? Kind of all basalt that's cooled and in some different shape.
All right. So Dave also follows up and asks, is there any sign of activity in the Lower East Rift Zone?
No, Lower East Rift Zone is still quiet. In fact, the easiest thing to look at is if we look at the GPS line here for the past year at Pu'o, we're still seeing a downward trend, right, showing that the Rift Zone is actually contracting at Pu'o, when Pu'o is a place that we believe has shown signs of being connected, with magma recently, and actually nothing past there. So anything Lower East Rift Zone, nothing really showing any signs below that, kind of just a long-term background now, whatever that may be.
Right. So we have one. We have two questions that really kind of go together here. Derek and Michael are asking about the lava samples. Derek asks if HVO is planning on taking a lava sample from the lake, and Michael asks, has there been any fresh sign of fresher lava erupting? And I have not heard anything about chemistry changes, he says.
I have not heard about that chemistry changes either. I am sure that they're collecting tephra every day. I mean, they did that every day for the whole 10 years of Summit Lava Lake and Halemaʻumaʻu 2008 to 18. So I'd be surprised if they don't have those downwind collectors and they're collecting and empty.
Right.
You empty it out every day. That way, the next day you know that everything in that, normally it's like a big sieve, like a drawer with a screen bottom kind of thing, right? And you put it on a tripod off the ground, so stuff's not blowing into it, but it has to kind of fall from the sky. So you're not getting something from the ground. It has to kind of come from the air. You go and you empty it every day, and go study it from there, right? How fresh, and you can whatever you want. So I'm sure they have lots and lots of samples. It's more about hearing the results. I haven't heard any results either.
Right, and it seems like people envision that there's some much more intricate and death-defying way of collecting samples from this eruption than just setting out a Tefra catcher. They kind of it seems like they envision some Mission Impossible scene with a guy in a Teflon suit hanging from a wire from a helicopter or something. But no, it's pretty boring comparatively.
Yeah, well, we haven't. Interesting what you call that a Tefra catcher, right? So in the Pu'o days, they actually would lower a bucket down over the crater wall. Often you couldn't see what was going on, and the fountain thing was really low in there. You couldn't see, so you actually had what they called tear catchers, and you'd lower them down and put the same thing every day. Pull it up, lower it down, pull it up. Lower. I mean, maybe not every day, because maybe every week when you flew out there.
Right.
Yeah.
Definitely.
That was slightly more exciting.
Awesome. Right. This one's a passive Tefra catcher.
Yeah. Yeah, you often you see that in some videos. Some guys rappelling down a crater, and it's it's awesome, but it's not necessary to put it that way.
Right. Idaho Hana asks, did the last eruption actually have polarity anomalies, and do we know anything about now?
Polarity anomalies. I'm not sure what he means by that exactly, right? So as far as a whole Earth magnetic field, that's kind of happening independently. Where I can take it, I'll just spin it my own way, is, our rocks are made of lava. Our lava has a lot of iron. When our lava flows, it actually induces an electromagnetic field around itself. So it does kind of have electrical effects, that especially while the lava is moving, and especially when you remember having that river of lava in 2018, that was moving so far and so fast. And you measure how much volume was flowing through that whole river. You probably could calculate the magnetic field being generated. We'll leave that as an exercise for one of our viewers to share with us, perhaps. I'm not going to go there, but that's an interesting thing about it. As far as so when we had lava flowing through lava tubes, they also would measure the distortion of the ambient electrical field, and but in that manner calculate how much lava was flowing through the lava tubes.
Very interesting. While we're on that topic of that level of questioning, Peter asked, would a change in Earth rotation speed or axis affect the volcanoes?
It probably all depends on the speed, right? There have been all kinds of proposals in geology for different ways that you get from point A to point B, right? We know that kind of reversals can happen. We know that tilt axis deviations happen, but we don't know a whole lot about the rates of change, and that's kind of it makes a difference whether it all happens in 1 year or in 10 years or 100 years or 1,000 years, which are all geologically short, but to us make a huge difference if, like, from 1 year to the next, your compass stops working, or everyone's there's magnetic storms every day of the week or something. So there's all kinds of uncertainties there, right? If it happened really fast, some of the more extreme proposals are that the whole shell of the Earth could kind of spin independently from time to time, like independent if it needs to adjust somehow. Like if it starts wobbling, then maybe it can adjust in some way. And maybe if you had some kind of jerky motion, that's kind of just all speculative at this point, then maybe you could have it really affect the volcanoes by straining and cracking, and just messing with the whole forces all around there. That's pretty extreme thinking. Probably something we'd never see.
Right. Nicholas asked, does HVO use mass spectrometry?
I do believe that they have that in collaboration with the University of Hawaii. I'm not sure exact details, but yeah, there is collaboration there.
I believe that. Okay, Big Ron has one question we've already touched upon, but maybe we'll end upon this one. Big Ron asks, if the SO2 emissions are decreasing and the latest lava is described as frothy, what other gases are embedded in the recent emerging material?
Yeah, that's a great question, because it's all relative, really. It's hard to really tell. Let me go back here to this photograph and just point out that even though the amount of maybe it's a matter of kind of the nozzle. Like we see this small nozzle and all the lava, the west vents coming out of this one little hole right here, right? And they're actually saying there's actually an upwelling right in here that might be 1 or 2 meters or more high, right? So almost like a standing wave right over here, where it's kind of welling up and in. So it could be that it's coming in still frothier, but there's less of it coming in, maybe, and maybe that's why there's a lower gas amount, perhaps. It would be great if we could know the gas amount hour by hour to see if it's changing and dropping and peaking, and where these once every few day measurements fall into that pattern.
Right.
Yeah. So, but yeah, it's interesting. There could be, I've described, it's mostly sulfur dioxide in there. You can have some water vapor. There's other, CO2 sometimes, although CO2 comes out a lot sooner. So I won't go into.
Well, we no longer have to talk about how that SO2 signal might be getting masked by the water lake. That's no longer a thing.
Right.
Small victories. All right. Well, that does it for me on the questions right now. Actually, there is one more from Nicholas. Will magma output decrease as Hawaii moves off the hotspot conceptually?
Yeah, conceptually, yeah. You would imagine in the long term that the supply to Loihi increases as the supply to Maunaloa decreases. Right, kind of as Maunaloa is on its way out and Loihi is on its way in over the center of the hotspot. They're both over the hotspot, right? But they're kind of a different stages. Loihi's coming onto it, and Maunaloa is kind of going off of it. But then you have the caveat that the crust is gonna continue to carry effects for many millions of years, and the plume is dragged out underneath as well. So, right. We talked about young eruptions on Oahu, on Maui. So you're never kind of quite out of the woods, but it does get a lot less frequent. That's essentially it.
Well, that does it for me. We are brought to you by Hawaii Tracker, hawaiitracker.com. If you like this content, the best way to support us is through liking and sharing this material. We don't have the advertising budget of many media organizations. We rely on word of mouth, people like you sharing this content. Secondly, hawaiitracker.com, become a member there, become a user. We're trying to build a different kind of social media where it's community focused. And third way is to go on hawaiitracker.com/support. And that is ways to support us directly. And that keeps us being able to do the research and to provide you with this type of content. So thank you, Phil, for this afternoon. Thank our super chats. And yeah.
Yeah, mahalo, everybody. Yeah, for Dandy Pond, I'm Philip Ong. We'll see you guys on Monday. Aloha.